Hello and welcome to Amulya's Academy YouTube channel. Today in this tutorial, let's analyze time and space complexity of jump search algorithm. Here we want to analyze the time and space complexity of jump search algorithm, not the whole program. That's why we'll analyze only this part. First, let's talk about time complexity. Here the first line is function definition or function header. Simple operation, and this operation does not depend on the input size, so it will take constant time. Next line is we'll find the length of numbers using length function, len function. So it is a simple operation, so constant time. Then we'll calculate step using mat.square-root function. It is a simple operation, so it will take constant time. Then previous equal to 0, an assignment operation, simple operation, so it will take constant time. Next, here we can see a loop, while loop. Here we will compare the target element with the last element of block one by one. If target is greater, then we'll jump to the next block. In the best case scenario, if our target is present in the first block, then that is the best case scenario. This condition becomes false here, so it won't execute while loop body. It will execute this condition only once, so it will take constant time. And here next we have for loop. Here also in the best case scenario, if our target element is the first element of our block, then it will execute only once, constant time. Then here we can see return operation. It is a simple operation, so constant time. So in the best case scenario, time complexity of jump search algorithm is constant time. Now what about the worst case scenario? That is when element is not present in the given list or it is present in the last block. So in that case, here function header constant time, length constant time, step constant time, previous equal to 0 constant time. Here in the while loop, if element is not present, then we'll execute this square root of n times, right? So here time complexity is big O of square root of n. And now coming to the for loop, here also if our element is not present in the block or if the element is the last element of that block, then it will execute square root of n times. Worst case scenario, big O of square root of n. Then return operation, simple operation, constant time. So in the worst case scenario, time complexity of jump search algorithm is big O of square root of n. Okay, so this is about time complexity. Next, let's talk about space complexity. Okay, here first line, function header. Here it will take constant space because it only stores reference to parameter and does not allocate memory proportional to the input size. Next, n, step, previous, these are all the variables. It will take constant space. And here I is a loop variable, constant space. Here we are not creating or using any data structure or recursion. This algorithm takes constant space. So space complexity of jump search algorithm is big O of 1. Okay, so this is about time and space complexity of jump search algorithm. That's it for now, guys. Thank you for watching. Don't forget to subscribe to my channel. I will meet you in next class. Till then, take care.